Yeah, very good evening, all. So let's start this session. Did everyone join it? Okay, fine. So let me start. See, we are looking for the applications of diodes, right? So we are looking for the applications of diode. What we saw in the last class, we saw how to design clippers, right? We saw very few clippers. Let me take few more examples for better understanding. However, diode is acting as a clipper, right? Okay, let me take few more examples. I think I had given some example, that is I had given some homework, right? Questions. I don't know how many of you had drawn the answer for that is waveform for the given diagram. Anyway, let me demonstrate few more examples. Let us take few more circuits and I will draw all the waveforms, right? And then you please try it by yourself, right? That example that I had given yesterday. Okay, let me take few more examples. Once again, let us consider a purely sinusoidal signal from the input side, and it will be connected with a diode. Once again, let me take some diode like this, and here now I am going to connect some resistor with some voltage also, right? Simply understand. Okay, I am not going to take any general values. Let me take hereafter I am going to select some standard values for our circuit. Some type of circuits will be given like this, and we are going to pump the input voltage from here. Okay, let us see your input voltage. Let me select some 10 sine omega t sinusoidal input signal, and here I am taking some voltage, right? And let us take that voltage level is, let me consider some 2 voltage, and let us fix some value of resistance here, right? There is some value of resistance will be there. Okay, this is our diode. Your diode has two terminals, one is anode and another one is cathode. Now the question is, we have to draw the waveform for the output voltage V naught. Shall we start? Yes, let us start the journey. Right now, to draw the waveform, let me take first we have to consider input voltage, right? So here first thing is we have to consider input signal. Which type of signal that we are passing from the input side? Our given input is sinusoidal, so this is going to be our standard input signal. Now if you are waiting for the output waveform, let us see, this is going to be your output, that is input signal with respect to omega t only. Let us see, let us observe the output also. This is pi 0, here it is going to be 2 pi, right? Now our target is we have to achieve the output waveform also positive off cycle, and again we have to consider negative off also, right? Now in the positive off cycle, this is going to be your plus, and this is, here we are having negative terminal, such that this positive terminal is directly connected with the anode, whereas this negative is directly connected with the cathode. But if you observe this circuit carefully, we are not only having this 10 sine omega t in the output port. If you observe carefully, there is one more voltage source, that is 2 voltage, right? Now this is positive 2, see there, plus is connected with the plus, positive terminal of the battery is connected with the positive terminal of the output, negative terminal of the battery is connected with the negative terminal of the output. It means in the output side the connected battery is positive battery, right? So let me consider that level of voltage is 2 voltage. Let me consider with the input signal. Now see there, or we can simply say supply is connected with the anode, battery is connected with the cathode, right? So in the positive, in this case, positive signal is connected with the anode, right? Whereas negative means zero voltage, we don't need to be panic. Similarly, see there, positive terminal of the battery is connected with the cathode. Now in case number 1, right? So let us consider, let me take this point, right? So let me denote it by theta 1, right? So let us consider this point is, or let me consider t1, and here there is one more point. Let me consider this point, let me consider that point is t2, right? This point is t2, this is pi is here. Let us start our journey here. The thing is, listen guys, careful observe pannunga. See there, in the positive off cycle, this is anode voltage, this is anode voltage, and this is your cathode voltage, correct? Cathode is connected with the 2 voltage, anode is connected with the supply. Now your supply voltages keep on rising exactly at omega t equal to T1. That is the point where your supply voltage and that is voltage across the anode and voltage across the diode, that is cathode, will become equal to each other. Getting me? Prior to that point, the voltage across the anode is keep on increasing, but it is not greater than cathode voltage. See, when your diode will turn on whenever the voltage across the anode will become greater than the value of voltage across the cathode. Across the cathode I have 2 voltage, across the anode now only we are pumping the voltage. Our level of the voltages keep on pumping. See that this is the point where anode voltage and the cathode voltage will become equal. Immediately after crossing this point, when the anode voltage will become 2.00001, see there my input signal is keep on rising. What about its maximum value? Input signal maximum value is plus 10. What about its minimum value? Minus 10. It lies in between plus 10 and minus 10 because I am considering 10 sin omega t as our input signal. Now if you observe this waveform carefully, see there my level of voltage is pumping correctly. Exactly at this is the point where your voltage will become what? Anode voltage and the cathode voltage will become equal. After this point, right, again if you observe carefully, after this point, right, this is anode voltage. All the anode voltages are going to be greater than the value of cathode voltage. See there across the cathode voltage is fixed. But across the anode from this point to this point, all the voltages are going to be greater than the value of the cathode voltage. Getting me, guys? There are no big things to understand. Cathode is connected with plus 2 voltage, anode is connected with plus 10 voltage. But this 10 voltage is not constant. This is not DC, this is AC. This AC is keep on rising, right? First it is 0 and then slowly rising 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, like 1, 1.2, 1.7, 1.8, 1.9. Exactly. When it is become 2, that is the point. Immediately your diode is going to turn on. Okay, sir, fine. Now the conclusion is what? From 0 to T1. The first conclusion is from 0 to T1, your diode is turned off. Why it is turned off? Why? Because voltage across the anode is less than the value of voltage across the cathode. Cathode is having 2 voltages constant, sir. So up to T1, up to this point, right? What is the output voltage? Up to T1, your diode is open circuit. If your diode is open circuit, then see there, I have input voltage, but diode is open circuit. But in the output side, if you observe, we have a battery, and here we are going to observe the output voltage V0, and our battery voltage is going to be 2 voltage, right? But the circuit is what? Open circuit. In open circuit, current delivered by the source will be 0, na? Yes. So here also we are receiving 0 ampere. Now tell me, what is the voltage drop across the resistor? Sir, 0. Why? Because current is 0, sir. V is equal to I into R. Since I is 0, na, so there is no voltage drop across the resistor. So we can simply say voltage across the resistor is 0, sir. Then what is the output voltage? Output voltage equal to, see there, though the voltage drop across the resistor is 0, the positive terminal of the battery is connected with the output positive terminal, negative terminal of the battery is connected with the output negative terminal. So the conclusion is from 0 to T1, your output voltage is equal to battery voltage, right? So now what is the battery voltage? That is 2 voltage. It will be appear in the output side. Now exactly after T1, voltage across the anode will become greater than the value of cathode voltage, because cathode is having only 2 voltage, but my anode voltage is keep on pumping. See there, after this point my level of the voltage is keep on rising. It means your diode is going to turn on. Once your diode will turn on, then your diode will be short circuit. Again if you redraw the new circuit after T1, let me take this circuit once again. If you observe the new circuit, sir, after T1, your supply diode will be short circuit, right? Diode will be short circuit, and now you may have resistor and a battery. Now I can define the voltage in 2 ways. The first way is, see that, listen here, current will go. Now your diode will be turned on, no? Diode will be short circuit. So your supply will going to supply some voltage, right? That is, your supply will going to supply some voltage and a current, right? So current is started flowing into the circuit such that across the resistor you can experience the current flow. Now here we have the voltage drop. Let me define, this is voltage VR, right? Something that is 2 voltage. Let me generally define. Okay, if you want to take 2 voltage, we can take, no problem. Now you please tell me, what is the output voltage? See there, positive terminal of the supply is directly connected with the output terminal, negative terminal of the supply is directly connected with the output terminal. So I can say V0 is equal to Vn. That is one way. The alternative way is, see there, across the output terminal we have 2 people. One is our battery, another one is voltage drop across the resistor. So output can also be defined as voltage drop across the resistor plus battery voltage, that is 2 voltage. This is also correct, right? So what is the conclusion? Output voltage is equal to input voltage, or output voltage will be the combination of, see, very simple, this is total supply voltage. This voltage will going to be what? Contributed with the resistor plus battery. That's all. So what is the conclusion? Sir, after T1, anode voltage will become greater than the value of cathode voltage, so your diode will be short circuit. So input voltage simply reflected in the output voltage. So whichever the waveform that we are having in the input side, this is our sinusoidal waveform that will be reflected in the output. But it will be continuous up to T2, that is T2. After T2, what will happen? See there, my input voltage is again, I was going like this, I was going. After, again I am falling down, I am sliding, keep on sliding. After reaching T2, my input voltage will become less than the value of the battery voltage. So what will happen? See there, if you observe carefully, all the input voltage values are going to be, see there, hereafter you may consider positive signal, negative signal, all the values are going to be less than battery voltage. Yes or no? Battery voltage is 2 voltage, positive 2 voltage, but you observe your cycle is what? Input signal is what? Here I may have positive voltage, but that positive voltage is less than cathode voltage. Across cathode we have 2 voltage positive, sir. Again see that your input signal is going to be negative now. Negative. All the values are less than battery voltage only. So what is the conclusion? In the positive half cycle from T1 to T2 is the only point where the voltage across the anode will become greater than the value of the cathode voltage. Diode will turn on, output will follow input. After T2, for all value of input signal, it may be positive or negative, it does not matter. For all value of input signal, your diode response is what? Your diode will block the input signal. Why? Because voltage across the anode will become less than the value of voltage across the cathode. Getting me? So what will happen? For all these input values, your diode will open circuit. If your diode will be open circuit, then battery voltage will be reflected in the output, right? So what is the conclusion? If you draw the waveform from T2 up to 2 pi, this is the waveform that we are going to receive in the output side. You can again continue, right? So after 2 pi, you will observe same waveform. You will get the same waveform. It will be continuous. Clear? So that is how you are clipping your output voltage with the help of what? That is input signal. Whichever the portion that you want to clip, you can clip it with the help of what? With the help of diode, and that is with the help of diode. Clipper, yes. So let us continue. Let me take few more circuit size. Now I am taking the same circuit, but I would like to reverse the battery polarity. Let me reverse. Here I am considering negative and positive at all, right? Now this is going to be minus and this is going to be plus. Now what happens? Let's draw the waveform. Okay. Again, we have to consider input signal. With respect to omega t axis, we have sinusoidal signal as the input, right? Now let us draw the output. This is omega t. Let me draw a line here. Let me draw one more line. Now what I am going to do, the thing is, sir, this is input voltage. Okay, and here it is going to be output voltage, V0, right? So what is our next target? We have to draw the waveform. Once again, we have to draw the waveform. See, just to think about it, sir, here negative voltage. Minus in the sense, we can consider, listen, if we are considering this positive voltage across the positive plate, then across the negative voltage we have 0. Across the negative plate we have 0 potential. Suppose if I am considering, இங்க நீங்க +2 அப்படின்னு consider பண்றதுக்கு பதிலா இத நீங்க -2 voltage அப்படின்னு consider பண்ணீங்கன்னா, it means we are considering this potential across the negative plate. Across the positive plate we have 0 voltage. Getting me? இங்க நான் என்ன ரெப்ரசன்ட் பண்ணிருக்கேன்? +2. It means with respect to positive plate we are defining the voltage. If you are defining the same voltage with respect to negative plate, then this voltage can be defined as -2 voltage. Am I correct? Yeah, I'm correct only, right? I'm defining this voltage with respect to negative plate now, right? Okay, coming back, the conclusion is, now in this case, we have -2 voltage. See there, negative plate of the battery is connected with the output, positive plate of the battery is connected with the negative of the output. It means battery voltage is opposite to output voltage. First thing. Now it is what? Battery voltage is -2 voltage, right? -2 voltage means its level is somewhere here. It is -2 voltage. -2 voltage. Now let us draw the waveform. Now we know how to draw the waveform. First thing is, listen, this is the voltage that we are going to inject across the anode. And across the cathode we have constantly -2 voltage. Across the cathode we have constantly -2 voltage. Now you please tell me at which condition your diode will turn off, at which condition your diode will turn on. Shall we start the journey? Yes. First, once again I am considering same positive and negative voltages. Positive and negative voltages. Now let us see how to draw the waveform. Okay, the thing is, listen, we are starting with the positive half cycle. See there, anode is connected with the positive, whereas cathode is connected with the minus 2 voltage. Cathode is connected with the minus 2 voltage. So what is the conclusion here? For anode voltage, though your anode voltage is positive in the sense, see there, all positive values, like it might be 0, 0 0.1, 0 0.2, 0 0.3, 5, 10, again minus 2, sorry, again 7, 6, 4, 3, 2, 1, 0, again minus 1, minus 1.1, minus 1.3, all the values are going to be greater than the value of cathode voltage, because cathode is connected to minus 2, negative potential, sir. So we are feeling very happy. Up to this point, your output voltage will be what? See that your output follows input. Am I correct? Yes, your diode will turn on. Your diode will turn on. Up to which point your diode will turn on? From 0 to, let me define this point is, where is that point? Yeah. Let me define this point is T1. Let me define this point is T2. Okay. Now up to T1, right? Up to T1, see there, all values of your voltage across the anode is going to be greater than the value of voltage across the cathode, sir. Now, you please tell me whether your diode will turn on or not. No, sir. Sorry, your diode will turn on, sir. It will be short circuit, right? So, what will be the conclusion here? The conclusion is your diode will turn on and your input waveform will be reflected in the output up to T1. Okay, sir, after T1, what will happen? See there, after T1, the voltage across the anode will become, see there, for an example, we are going up to minus 10 voltage, na? So, see there, here we have minus 2 voltage. Now, minus 3, minus 4, minus 5, minus 6, minus 7. These are all the negative voltages that are going to be injected across the anode. Now, you please observe, negative voltage in the sense, negatively, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10. All values are less than minus 2. Do you all agree with me? Yes, minus 2 is greater than minus 3. Minus 2 is greater than minus 4, minus 2 is greater than minus 10. So the conclusion is, for all these negative values, voltage across the cathode will become greater than the value of voltage across the anode. So your diode will be open circuited. Once your diode will be open circuited, then the battery voltage will be reflected at the output port. So what will be the conclusion? Battery voltage will be reflected in the output port. Exactly. Up to T2, this situation will be continuous. Then what will happen? My sinusoidal signal won't stop. It is keep on running, again getting back to minus 2. And then this level is increasing. Minus 2, it is going to less than minus 2. Minus 2, and then it will reach minus 1.999. That is the point. You please tell me, minus 1.9 is greater than minus 2 or not? Yes. Minus 1.9 is greater than minus 2, sir. So immediately after crossing this junction, voltage across the anode will become greater than the level of voltage across the cathode. So again your diode will turn on and input will be reflected in the output side. Clear? Yes. So that is how we are drawing the output waveform. Now I am introducing one more person here, that is called transfer characteristics. What do you mean by transfer characteristics? Transfer characteristics is the relation between input voltage waveform and output voltage waveform. I hope now you all are getting how your diode is simply working with the AC signal and how it is clipping the unwanted portion of our signal. Now it is the time to learn the next part of your clipper, that is called transfer characteristics. Let me define the transfer characteristics, right? That is very, very important, and in your examination, some general circuit will be given to you. Don't memorize anything in analog electronics also, because there are no things to memorize. I already told you KCL, KVL, nodal. This is the 3 laws that I am going to standardly use to complete the whole analog electronics, right? Let me prove it. Don't worry. That is that much easier analog. Yeah, let us draw the transfer characteristics. So our next target is we have to draw the transfer characteristics. Keep the heading, that is the transfer characteristics of the given circuit. Let us draw transfer characteristics. See, you can give the name. Well, if you are clipping positive portion, then that is called a positive clipper. If you are clipping negative portion, then that is called a negative clipper. If your diode is connected in series with the load, then that is called a series clipper. If it is connected in shunt with the load, then that is called a shunt clipper. Like that we are giving names. But I don't want to name that things. First you have to generally understand. Right? And if I am clipping more than one portion, then that is called a 2-level clipper. Like at the same time, right? At the single time, we have to clip positive as well as negative also. Then that is called what? 2-level clippers, right? Or in the positive itself, right? We can clip 2 portions, right? If you are clipping 2 portions, if you are clipping more than one portion, then that is called what? Multi-level clipper, right? So like that we can name the circuits, but should try to understand the procedure here, right? Yes. So let us coming back. This is the transfer characteristics. Now, what do you mean by transfer characteristics? Transfer characteristics in the sense we need to draw the waveform between input voltage and output voltage, right? So let me draw. So here we are going to consider input voltage, right? So this is our input voltage, positive, and here it is going to be negative input voltage, and this is our output voltage, positive output voltage. This is our negative output voltage V0. Now let me draw the transfer characteristics, the relation. Guys, listen. Actually, this is our input signal, right? Exactly, sir. This is our input signal. Now what I have done here, see, your input voltages keep on increasing. Now see there, from 0 to T1. First, let me consider positive cycle, 0 to pi. See there, in the first quadrant, you are supposed to consider the positive cycle of the input signal. In the second quadrant, right? So here you can consider the negative signal, right? That is the negative off. You can consider negative off here, consider positive off here. Let me draw. Positive cycle in the sense we should go from 0 to pi because input is positive. Here only we have positive voltage. Na? So let us consider certain distance 0 to pi. Now what I am going to do, for 0 to pi we are keep on increasing the value of input voltage. Yes, our input voltages keep on increased, right, from 0 to pi. See there, first let me break it into two off. 0 to pi by 2, my input signal is increasing, and then okay, it is better to go up to pi by 2, that is much better, right? So guys, listen, here I am not having value, sorry, I am not having time axis. This is input voltage magnitude. For your understanding, I am taking 90 degree and I am increasing up to 90 degree. Your level of the input voltage keep on increasing, right? Yes, up to 90 degree. Now you please tell me, what about the output voltage? See there, input and output are same. Input and output are same from 0 to pi by 2. Do you all agree with me? Yes. Sir, when I am increasing the input voltage, output voltage also what? Will increase with the same proportionality. With the same proportionality. If your input is 0, output is 0. Input 1, output 1. Input 2, output 2. Input 10, output 10. So what type of waveform that you will get here? If your input is 1, output is 1. Input is 2, output is 2. Input is 3, output is 3. Input is 10, output is 10. What is this? This is ramp waveform. Am I correct? Yeah. After pi by 2, see there, after pi by 2, again, input is decreasing, output also decreasing. Just consider the positive waveform. Input is decreasing, output also decreasing, sir. See there, here I am reaching what? 10, 9, 8, 7, 6, 4, 3, 2, 0. Here also, same, 10, 7, 6, 4, 2, 0. Same proportionality. So again, after pi by 2, once again, your input voltage is decreasing, output voltage also decreasing to 0. Getting me? So here in one complete cycle, in the positive off, right, in the positive off, first I am bumping the value up to 10, again I am getting back to 0. It is over. Up to pi is over, right? First we are pumping the value to maximum 10 and then we are getting back to 0. So positive cycle is over. Now it is time to consider the negative waveform also. What is the negative voltage? See there, this is the negative waveform. This is the negative waveform. In negative, only for a certain portion your input is following the output. Your output is following the input only up to certain portion. For an example, what is the certain portion? We can exactly define. Here I took the example value as -2 voltage. So your input voltage is now it is started traveling towards negative. Like negative in the sense 0, -0.1, -0.2, -0.3. Like that it is keep on raising, pumping up to -2. Pumping up to -2, then what will happen? Up to -2, input waveform and output waveform are same, sir. Just observe, up to -2, whichever the value that we are giving in the input side, same value that we are receiving in the output side, sir. So what type of relation? Again we are going to get what? What type of relation? Linear. Linear means what? Ramp, right? So sir, input is increasing, output also increasing, but towards negative direction. If it is -1, it is -1. If it is -2, it is -2. Yes. So same waveform. But up to only -2, up to -2. Next what will happen? After -2, just observe. Sir, after -2, what happens here? One second. Yeah, after -2, what happened? My input signal is increasing, sir. We are pumping. See there, I am pumping the input voltage towards negative off, right? Negative in the sense it is going -1, -2, -3, -4, -5, -6. Like it is going to bump, that is bump its value up to what? It is pumping its value up to 10, -10. It is pumping its value up to what? -10. But the problem is, when your input is reaching -2, that is the point where your output is stopping following what? It stopped following input. See there, after -2, though we are pumping the input voltage up to -10, output voltage should be restricted to -2 only. It is fixed. See there, if you go, this is the maximum point of the input signal, maximum negative point. So up to -10, see there, from -2 to -10, though we are increasing the input voltage, output voltage will be fixed. Output voltage will be fixed. It is -2 only. It is -2. So what is the conclusion, sir? After this point, output voltage, see that input voltage is increasing, but output voltage will be fixed. Fixed as what? -2. Then what will happen after 90 degree? Again we are getting back. See there, after 90, again we are getting back. So again your input level is keep on decreasing like this. This curve is decreasing. But what's wrong with that? Till your output is what? -2 only up to this point. When your input voltage will become greater than -2, when it is going greater than -2 in the sense -1.999, that is the point. Once again your output is started following input, again you are getting same waveform. See there, I was standing at 0, going to -2, again up to -10 there is no changes, it is constant. Again we are getting back to -2, again we are getting same waveform. So first positive half cycle is over, now negative half cycle also over. See there, we are considering, actually we are drawing the waveform for 180 degree only. It means, see the positive half cycle, I was going from 0 to 90, again 90 to 180, same waveform. Here from 90 to 180, from 180 to 270 I was going, again from 270 to 360 we are getting same waveform. There is no changes, right? Positive half cycle and negative half cycles are same na. Here also positive half cycle, negative half cycles are same na. So we are drawing only for 180 degree. It means 90 90 180, 90 90 180, total 360, right? Inga positive quadrantல நீங்க 180 complete பண்ணுவீங்க, negative quadrantல 180 complete பண்ணுவீங்க. But 180 னா we are going இப்படி போயிட்டு இப்படி ரிட்டர்ன் பண்றீங்க. அப்படிதான் waveform போகுது. See that, pumping down, it is pumping up, pumping down. So pumping up, pumping down, pumping up, pumping down. Clear? That is how we are developing transfer characteristics of the waveform. I hope this is the most important part of your clipper, because you will be tested for worthless 2 more questions. Just by looking at the question itself, you can guess what type of characteristic waveform that you are going to receive for the corresponding clipper. You will be tested for 2 more questions, right? Fine. So let us take few more examples. Class is going good, I hope. Okay, fine. 1 second. Sorry for the interruption. There was some interruption from my side. Okay, let us continue. Once again, let me take some input signal. Let me consider some resistance. Okay, let us consider some diode here. Let me connect some battery also for a better understanding. Okay, again we are going to pump the voltage from here. Take same 10 sin omega t, and here it is our diode, and this is take same 2 voltage. You have to understand, that is one and only thing that I am expecting from your side, right? Circuits are very easy. Can you please draw the waveform? Let's try. Okay, again first consider the input cycle. Input means we are passing sinusoidal signal. Okay sir, now we have to draw the output waveform. This is omega t, and here it is omega t. Let me draw the output waveform also, right? Yes, so here it is going to be pi 0, and we are running up to 2 pi. Yes, from the input side we have a signal. Similarly, output port we have some battery. Battery is what? Positive terminal of the battery is connected to the positive, negative is connected to the negative. So it is what? Positive voltage, right? So let us consider 2 voltage also, right? So here we have 2 voltage battery also. But in this case, we have to observe carefully. The thing is, sir, cathode of the battery is connected to the supply. Cathode of the diode is connected to the supply. Anode of the diode is connected to the battery. Getting me? Where is your anode? Where is your cathode? Sir, here we have anode and here we have cathode, sir. Okay, let us continue the journey. Let's see what will happen. It's quite interesting, right? So case number 1, when we are considering positive cycle, just observe, when we are considering positive cycle, right? So let me define. Once again, this is T1. Let me name this point is T1, and let us name this point is T2. Okay, fine. It is much better. Okay, sir, from 0 to T1, first of all, Sinusoidal signal is connected with the cathode terminal. Battery is connected with the anode terminal. When your diode will turn on, whenever the voltage across the anode will become greater than cathode voltage, that is the point where our diode will turn on. Now you please tell me from 0 to T1 whether your diode will turn on or not. My answer is your diode will turn on. How, sir? Just observe. See there, from 0 to T1, right? From 0 to C1, see that this is the voltage, available voltage across the cathode. Right, so slowly I am pumping the voltage from input side. We are pumping, right? So slowly our level of the voltage is pumping from 0 to 2. It is rising, sir, not reaching 2. It is slowly, it is less than 2. See there, it is less than 2. Whereas the voltage across anode is 2, fixed DC voltage, right? So we have fixed voltage across the anode terminal, whereas up to this point, all the voltages, right? Anyway, we are keep on pumping, but the pumping level is less than the voltage across the anode. Definitely diode will turn on. Now you please tell me, if your diode will turn on from 0 to T1, what will be the output voltage? Can you please tell me? Sir, if your diode will turn on, then carefully observe. Here we have the input signal. In between the output and input, we have some resistor. Restricted. This resistor will create some drop here. Anyway, simply I can say, if your diode will turn on, then the positive voltage, battery will be connected with the output directly. So your output voltage will be simply equal to battery voltage. Getting me? See there, if your diode will turn on, then how a circuit will look like in the output port, you can observe. Your battery, diode will be short circuit, and this is going to be positive terminal, this is going to be negative, positive, negative, that is going to be 2 voltage. It will be simply connected like this. So we can say output voltage V0 is simply equal to 2 voltage, sir. Any mistake? No. Let us draw the waveform. So from 0 to T1, output voltage is 2 voltage. From 0 to T1, output voltage is 2 voltage, sir. Next, sir, after T1. After T1 up to T2, see there, this is the amount of voltage that I am passing, or still input voltages keep on pumping, na? So after after passing this 2, all the voltages that we are passing from the input side will going to still again it is going to cross the cathode junction, but these all voltages levels are going to be higher than the value of the positive voltage that we are injecting across the anode. See there, cathode voltage will become, these all are cathode voltages. So cathode voltage is greater than anode voltage or not? Yes, sir. From T1 to T2, anode voltage is 2, but cathode voltage is greater than 2. If your cathode voltage is greater than anode voltage, then diode will be open circuit. If your diode will be open circuit, then what happens? If your diode will be open circuit, then if I will redraw the waveform, if I will redraw the circuit, see there, though I have some resistor here, diode is open circuit, na? It means it is completely open, sir. So it is complete. This is your new circuit. Battery will become useless. Why? Because this port is open, sir. This port is open. Now with the help of this battery, you cannot do anything. One point of the battery is disconnected from this circuit completely. Under this situation, if you observe the output voltage V0, this is going to be Vn plus or minus. Current divided by the supply is 0, so there is no voltage drop across the resistor, because V is equal to I into R. I is 0, so there is no drop across the resistor. If you apply KVL, then what you will get? See there, minus Vn plus V0 equal to 0, or I can say V0 equal to plus Vn only, sir. So from T1 to T2, this voltage will be reflected in the output side. This voltage will be reflected in the output side. Now from T2 to pi, from T2 to, this is where is pi? This is pi. Right, from T2 to pi, what we are going to receive? Once again, if you observe the waveform carefully, sir, from T2 to pi, anode voltage is decreasing, but cathode voltage is fixed. If you can observe carefully, see there, this all voltages are called cathode voltage now. See there, this is the voltage that we are injecting across the cathode. If you observe carefully, from this point to this point, cathode voltage is greater than anode voltage. But after this point, all the voltages that is going to be dropped across the cathode is less than anode voltage. Do you all agree with me? Yes, this is positive 2 voltage, sir, but this is, see there, less than 2, less than 2, less than 2. This is negative voltages. It is always less than 2 only. So here after this point up to 2 pi, all the input voltages are going to be less than the voltage drop across the anode. So definitely diode will turn on. If your diode will turn on, then this is the condition. Output voltage is fixed as what? 2 voltage. So the output voltage is going to be 2 voltage only, sir. We can fix it. Any mistake? No. So you please tell me, how will you draw? This is output voltage, it's over, right? So our next target is we have to draw the transfer characteristics. Try it by yourself and then check it with our answer. Let me draw the transfer characteristics. Transfer characteristics in the sense we should draw the waveform between what? Input and output, sir. This is output voltage. This is minus V0. This is input voltage. This is minus input voltage. Fine. Shall I draw the waveform? Yes. Let us draw. Let us draw the waveform. See, the waveform is, again we are going from 0 to pi. It's quite interesting, right? In the positive quadrant, take positive cycle. In the second quadrant, take negative cycle, right? Okay, let us go ahead with the first quadrant. Sir, positive cycle is keep on. I'm pumping the positive voltage. But one thing we have to understand, right? So we have to think here. Logically, we have to apply the things. Okay, anyway, I told you just to discuss up to 90 degree, right? From 90 to pi, you are going to get same response, right? Okay, sir, from 0 to 90. In between 0 to 90, actually, see there, my input voltage, I am keep on increasing the value of input voltage. But here, if you observe carefully, from 0 to input voltage is what? From 0 to 2 voltage. Here, 0. Initially, I am having 0 voltage. I am increasing voltage up to 2. Just let us discuss in between 0 and 2. Sir, while going from 0 to 2, input voltage is keep on increasing, sir, but output voltage is fixed. Are you guys understanding what I am trying to conclude? I am increasing the input voltage, but output voltage is fixed. How much? Output voltage is 2. Restricted, it is 2, right? Let's see what will happen. So output voltage is fixed. When input voltage is increasing, input voltage is going 0, 0.1, 0.2, 0.3, it is keep on increasing, but output voltage is fixed, sir, 2 voltage only. Okay, sir, after 2, what will happen? After 2, output waveform and input waveform are going to be same. Output voltage and input voltage are going to be same in the sense you are going to get linear waveform. If input is 3, output is 3, input 4, output 4, input 10, output 10. So input 3, output 3, input 4, output 4, input 10, output 10. See there, this is the waveform. Any mistake? No, sir. Coming back. Now, see there, next what will happen? See there, first 0 to 2 and then we are raising up to 90 degree only I am discussing. I told you, just to consider first 90 degree. Same 90 degree will be reflected because after 90 your waveform is decreasing, sliding down. It means you have to come back. So whichever the waveform that we have gone through, same waveform you are going to get. From 90 to 180, you will have to come back. From 0 to 90, 90 to 180. It's over. Coming back. After 180, let us discuss. Sir, after 180, if I observe the waveform carefully, see there, after 180, my input is pumping. Once again, we are pumping the voltage towards negative direction. I am pumping minus 1, minus 2, minus 3, minus 4, minus 5. What is the use? Just observe the waveform. Output voltage is fixed. Output is what? Minus 2. So, sorry. Output is plus 2. It is fixed, right? So, let us draw the output waveform. Still, I am keep on pumping the voltage, right? We are going up to what? From 180 to 270. Just to consider 270. We are pumping the voltage up to minus 10. Again, we are decreasing to 0. So, we are going from 0 to minus 10, minus 10 to 0, right? So, I told you just to go from 0 to minus 10. 0 to minus 10, I am keep on increasing the value of input voltage, but there is no changes. Your output is restricted, fixed. Minus 2, sorry, plus 2. Again, after 270 to 360, again, there is no changes, right? So, this is the transfer characteristics. Getting me? It's very, very, very important, right? Because I told you from the clipper portion, this is the only point where there is small type of tricks are begin the circuit. So, you will be often being tested in examination with these type of transfer characteristics only. So, please should try to understand the procedure. There is no procedures. Logically, you have to draw the waveform if your circuit is given to you, right? Yeah. I hope class is going good. Okay. Okay, let us consider one more circuit. I'm not exactly drawing this waveform, right? Okay. Okay, shall I draw the waveform? Yes, let me denote. Now we have two diodes, right? D1 and D2. Let us see what happens. Now if you observe, we are having two batteries here, right? Those batteries are, here we have plus 2 batteries there, also minus battery also available, right? So we have two type of batteries here, right? Positive battery is there, negative battery also will be there, right? Anyway, this is the point where we are going to measure the output voltage. Let's try, right? I too don't know what happens, right? Anyway, we are going to consider two voltages. One is plus 2 voltage, another one is minus 2 voltage. Let me name this one T1, this one T2, and this is pi, and this is T3, this is T4, this is 2 pi. Okay, see here we have the difference. Actually should try to draw the waveform exactly, right? One second. This is pi, this point is here. Okay, this is pi, this point is T3. Shall we start our journey? Yeah, I hope things are clear now, right? Yes, let's start the waveform, right? Let's start and draw the waveform. Anyway, let us discuss. There are two diodes, right? Two diodes are there, right? Now in the positive off cycle, we all know which diode will turn on. See there, anode voltage is going to be connected with the positive plate. Again, see this here, positive plate, positive supply voltage is connected with the anode of the first diode. Again, positive voltage, right, is going to be connected with the cathode of the first diode here, right? So this is going to be cathode, this is anode, this is anode, this is cathode. We all know, right? Yeah, one second, this is cathode, right? Exactly, that is correct, sir. Okay, let us draw the waveform, right? So first thing is, we know in the first diode, cathode voltage of the diode number 1 is 2 voltage, it is fixed. Similarly, anode voltage of the diode 2 is 2 voltage, sorry, minus 2 voltage, that is also fixed. See there, anode of the second diode is minus 2, cathode of the first diode is plus 2. These two voltages are fixed, right? Let us see. Now what I am going to do, let me plot these things. Plus 2 voltage means that is, this is the cathode voltage of the diode 1. Minus 2 voltage, that is the anode of the diode 2. That is the anode voltage of the diode 2. Slowly observe. Let's see what happened. Now case number 1. So the thing is, if you want to turn on the first diode, right, when this diode will turn on? This diode will turn on when the voltage across the anode will become greater than the value of cathode voltage. Exactly, that is true, sir. So under that situation, let us see what happens. If when this diode will turn on, this diode will turn on when anode voltage will become greater than cathode voltage. When anode voltage will become greater than cathode voltage, it will happen when your anode voltage will become greater than 2 voltage, right? Input voltages keep on, we are pumping after T1, input voltage will become greater than the value of cathode voltage. This diode will turn on. If it will turn on, then what happens? See there, here we have input voltage, and this is the point where we have the battery, and this is the point we are going to receive the output voltage, right? So let us see under this situation. Now first let us go from 0 to T1. Just observe from 0 to T1 whether this diode will turn on or not. No, it will turn off, right? So let me clearly demonstrate all these things, because you might be confused. While going from 0 to T1, first case, while going from 0 to T1, tell me whether this diode will turn on or not. No, sir, this diode won't turn on. Why? Because from 0 to T1, positive voltage, right? So we are injecting AC voltage here, that all the voltages are less than cathode voltage. So diode D1 will turn off. Diode D1 will turn off. At the same time, now you please tell me whether the diode D2 will turn on or not. Right, diode D2. Let us discuss from 0 to T1, same voltage, that is in the same situation. Here I am injecting what? Positive voltage. Across what? Across the cathode, we are injecting positive voltage, right? So same positive voltage will come here, right? And across the anode, we are injecting negative voltage, sir. If you want to turn on the diode, then the anode voltage will become greater than the value of cathode voltage. So what will be the conclusion here? Under this given situation, both of these diodes, if you observe this diode carefully, since I am injecting positive voltage here, but here available voltage is what? Negative voltage. Now with the help of negative voltage, you please tell me, can you turn on the diode? No sir, I cannot turn on the diode. So what is the conclusion here? This diode will turn off. This is also turn off, right? So we can see, so diode D2 also turn off. Diode D2 also turn off. Why it is turn off? Because the voltage that I am injecting across the diode D2 is what? It is less than the, it is greater than the value of anode voltage, right? So across the anode I am having 2 voltage, sir, but across the cathode we are injecting 0, 0.1, 0.2, 0.3 up to what I can see some positive voltages we are injecting, right? So the conclusion is, in the first half cycle, right? So in the first half cycle, this diode D2 is turn off, D1 also turn off, D2 also turn off. If both are turn off, then what is the conclusion? This diode will open circuit. What about this diode? This is also open circuit. Then what is the output voltage? 0, sir, right? So output voltage is going to be 0. There is no voltage in the output side. Let us see. After T1, let us see what will happen. Just should try to understand, because these all are my own values, right? These all are my own values. Whichever the values that I am considering here, for that I am drawing the waveform. So in your examinations, you will be tested with the general circuits only. I am repeating, right? Okay, fine. After T1, what happens? Sir, after T1, positive voltage, it is crossing, right? The level of the voltage is going beyond 2 voltage. So definitely, let us see from T1 to T2 up to this point, right? So let me discuss from T1 to T2, right? If you observe from T1 to T2, all the input voltages across the anode will become greater than, so let me consider, will become greater than battery voltage 2, right? So in between T1 and T2, definitely diode D1 will turn on. What about diode D2, sir? You please tell me. No, diode D2 won't be turn on, sir. Why? Because we are injecting what? Already here across the anode we are having negative voltage. So we cannot, when this diode will turn on, when anode voltage will become greater than cathode voltage. Now here, for all positive half cycle, this diode D2 is going to be turn off only. It will never turn on. So once your diode D1 will turn on, then what is the output voltage? If it is turn on, then you please apply KVL. Minus input voltage, right? Start from here, minus input voltage plus, it is turn on, it is short circuit, it is open, it is useless, but it is short. Then what is the output here? We have 2 voltage, and here we have positive voltage V0. So we can say output voltage equal to 0, that is KVL equal to 0. So from this I can say output voltage V0 is equal to input voltage Vn minus 2 voltage. Okay, I will draw the waveform, right? So let us continue. See there. Now from T1 to T2, we have to, this is our battery voltage, this is our input voltage, we have to do the subtractions. Anyway, listen, let me take 3, 4, 5, 8, 10. Again 5, 4, 3, 2. Right? Now let us make this subtraction. We are taking 10 sin omega t as the input, right? So maximum voltage is 10 only. We are going from 2 to 10. So let us take some value. 2, 4, 5, 8, 10. Again 8, 5, 4. See, approximate values. Don't think that these are the standard values. I am not considering like that. Just approximately I am taking some value. You please make subtraction. Sir, after T1, what will happen? We are going to do subtraction like this. 2 minus 2, 0. And then after, 3 minus 2 will become 1. And then 4 minus 2 will become 2. 5 minus 2 will become 3. 8 minus 2 will become 5. 8 minus 2 will become 7. 10 minus 2. Am I correct? Yeah, 10 minus 2 will become 8. Same values will be repeated. And if you draw the waveform, it is slowly rising and then again it is decreasing to see that. Exactly while reaching this point, right? While reaching this point, both voltages will become equal. Again, we are going to get 0 only. So let us see after T2 to pi. Let us consider from T2 to pi what will happen. From T2 to pi, once again your voltage is decreasing, right? The voltage across the anode will become less than the voltage across the cathode. So again this diode will turn off, right? So the next case we are going to consider T2 to pi. Sir, we can say from T2 to pi, once again the output voltage is going to be, sir, what will happen? You please tell me, diode D1 is turn on or not? No sir, diode D1 turn off. What about diode D2? D2 also turn off, sir. D2 never turn on in the positive half cycle, because across the anode we are injecting negative voltage. There is no chance to turn on this diode in the positive half cycle, right? Let us discuss. Anyway, from T2 to pi, both diodes once again turn off. If both are turned off, this is cut off. See, this is a disconnected open circuit. In open circuit, there is no current flow and we are not receiving output voltage. Don't think that, sir, battery is connected to the output, why not we can measure this voltage? This is wrong actually. Why? Because if it is open circuit, then one terminal of the battery is disconnected, sir. If it is see, இது open circuit ஆயிடுச்சு அப்படின்னா then what will happen? This positive plate terminal is disconnected. ஒரு பக்கம் ஓப்பன்ல இருக்கு, இன்னொரு பக்கம் கனெக்ஷன்ல இருந்தா நீங்க உங்களால கரண்ட் ஃப்ளோ கொடுக்க முடியுமா இல்ல அவுட்புட் டிரான்ஸ்மிட் பண்ண முடியுமா? You cannot do anything, right? So your battery has two terminal has to be connected with some closed circuit. One port, that is one terminal of the battery is disconnected and it is open circuited, another one is connected with someone. Can you pass any voltage? That is not at all being possible. It won't act as a battery. It is simply useless. It is simply sitting there, right? That's what happening here. So once again your output voltage is going to be 0. Sir, after pi, yes, see, let us see from pi to T3, this is pi up to T3, right? See the negative voltage. Now let us discuss about negative voltages. If we are injecting negative voltage across the anode, you please tell me, can you turn on diode D1? No. For all negative cycle, diode D1 will be permanently strictly turn off. Why? Because to turn on the diode, voltage across the anode must be greater than the value of voltage across the cathode. Unfortunately, across the cathode we are having positive potential, sir. So, but hereafter, after pi, from pi to 2 pi, all the input voltages are going to be negative, sir. With the help of negative, how can you satisfy the condition? You cannot satisfy the condition, diode turn off. So, D1 permanently turn off from pi to 2 pi. What about D2? Let us discuss. Now, across the cathode, we are injecting negative voltage. Negative voltage in the sense, first let us go from, what I can say, let me take pi to T3. Our next zone is pi to T3. Okay, let us discuss. Sir, pi to T3, right? If I am going from pi to T3, what will happen? You please just try. Sir, pi to T3, anyway, this diode is strictly D1 பத்தி நம்ம பேசவே தேவையில்லை, இந்த லைன் ரிமூவ் பண்ணிடலாம். ஃபர்ஸ்ட் கேஸ்ல இந்த லைனை ரிமூவ் பண்ணீங்களா, அதே மாதிரி இப்போ செகண்ட் கேஸ்ல இது ரிமூவ் ஆகிடும். Let us discuss. See there, from pi to T3, we are injecting first 0, minus 0.1, minus 0.2, minus 1, minus 1.2, minus 1.4, minus 1.8, minus 2. But all the negative voltages are, all the negative values are strictly, all the negative values are strictly what? All the negative values are less than, right? So sir, you please understand here, if you want to turn on this diode, the voltage that we are injecting across the anode has to become greater than the level of cathode voltage. But the thing is, listen, I would like to conclude one more thing. If you know the minus 0.1, minus 1, minus 1.5, minus 1.8, all are greater than 2 actually, right? Not less than, greater than. Yes or no? If the voltage across the cathode greater than voltage across the anode, can you turn on the diode? No, sir, diode won't be turned on. So what is the conclusion? Diode D2 is turn off, sir. Already D1 is turn off. D1 is permanently turn off in the second half cycle. So D2, D1 both are turn off. So once again voltage will be 0 up to pi 3, sorry, up to T3. Why, sir? Why? Because across the cathode we are injecting more amount of negative. See there, minus 0.1 is greater than 2. So greater than minus 2. We are injecting negative voltage. Minus 1.5 is greater than minus 2. Minus up to minus 1.999999. This diode won't turn on. But after crossing T3, see there immediately, all the input voltages are going to be, see there, hereafter minus 2.1. From minus 2.1 up to minus 10, all the values are less than anode voltage. Now see there, after 2 we are injecting what? Minus 2, minus 3, minus 4, up to we are going to travel up to minus 10. But all the values are strictly, let me take from 2.0001. But all the values are less than 2 voltage, minus 2 voltage. Getting me? Yes. So definitely this diode will turn on. If your diode will turn on, then let's see what will happen. If your diode will turn on, then the output voltage will become, see there, minus, sorry, we have to start plus Vn. Diode is short circuit, and here we have minus 2. And output voltage is once again plus V0 equal to 0. Or I can say input voltage, that is output voltage V0 will become equal to minus Vn plus 2. Minus Vn plus 2 voltage, right? Now, where is your output waveform? Sir, this is my negative voltage. This is my negative voltage. It has to be added with what? Just we have to do what? Minus Vn plus V. Where is our Vn? Vn is Vm sin omega t. This is our Vm sin omega t waveform. This is our Vm sin omega t waveform, right? So let us consider this Vm sin omega t waveform, and I have to add minus Vn is going to be added with plus 2. Plus 2. See, sign is being changed. It does not mean that here we have negative voltage only. But there in the output voltage what we are going to get, we have to add input voltage is simply being added with the plus 2. That is the voltage that we are going to receive in the output side. Getting me? Let us draw. If you do like this, after T3, first of all you have to understand one thing. What we are going to do, minus Vn will going to be added up with the plus 2. It means actually we are having negative voltages only. So I can say first voltage is minus 2. Exactly at this point we have minus 2 voltage. Minus 2 voltage plus 2 voltage will become 0. This is minus V in only, na? This is minus V in only, right? Negative voltage. Sir, okay sir, this is 0 sir. After that your input voltage will be raised to minus 3, it will go minus 4, it will go up to minus 10. Just add all these LSR will be added with plus 2 plus 2 plus 2, such that what you are going to get, it will become minus 1, it will become minus 2, it will become minus 8. So the level of the voltage is what? Keep on increasing, again it is getting back to 0. Getting me, sir? Inga voltage on the input voltage on the minus Vn with the plus 2, we have to add plus 2. So that is what I am doing. So here, exactly here, input voltage is minus 2. If I will add plus 2 with the minus 2, it will become 0. Then it is minus 3, minus 4, minus 5, minus 10. Right? Just add plus 2 with all this waveform, right? With all these values, you will get this waveform. Again, while reaching T4 at all, again what we are going to get? See, their input voltage will become once again minus 2. Minus 2 will be added up with the plus 2, again it will become 0. Now after this point, what will happen, sir? After this point, input voltage will be again pumped, right? So it is pumping to, it is getting back to less than minus 2, right? Less than minus 2, greater than minus 2. It will become minus 1.99, minus 1.8, minus 1.5, minus 1.2, minus 1, 0. All these values are going to be greater than minus 2. So definitely they will turn off. Once your diode will turn off, again already D1 will be turn off. Here D2 also going to be turn off. So this is your correspondent output waveform. It's quite interesting, right? Yeah, it is taking some, that is it's consuming our time, I know, but this is the one of the complicated circuit that I took. In your examinations at all, your questions will be chilly, right? These things at all, for your understanding, I'm going up with these type of typical questions, but in your examinations will be tested for some worthless questions, right? Yeah, let's continue the journey. So our next target is we have to draw the transfer characteristics, right? You please try. Let me rub these things. Let us draw the transfer characteristics also. Clipper is over with this. Okay. Now let us draw the transfer characteristics, right? We know how to draw. You please do it. Start panalama. Yes, right? In the first half cycle, this is going to be output voltage. Yes sir. Input voltage minus input voltage minus output voltage. First consider up to 90 degree. Okay, so in the 90 we have to start from 0, travel up to T1. See there, from 0 to T1 we are pumping the input voltage. See there, from 0 to T1, we are increasing the value. First 0 to 2, we can say exactly we are going up to 2, right? So your input voltages keep on raising up to 2 voltage. What about your output voltage? Strictly 0, sir. Output voltage is 0, sir. After T2, sir, after T1, what happens? Just observe. After T1, what will happen? After T1, we are increasing the value of input voltage. We are keep on increasing the value of input voltage. So based on the input voltage, what we had been observed, we all know after T1, what we got? V0 is equal to Vin minus 2. We saw. Up to 2, it is 0. After T2, after T1 to T2, output voltage will become Vin minus 2. We have seen that one. Anyway, what is the conclusion here? If your input voltage is increasing to 3, it will become 1, right? So slowly, see there, input is next. When your input voltage will become 3, output voltage will become 1. So somewhere here. When input voltage will become 4, just observe. 4 minus 2 will become 2. When input voltage will become 8, right? 8 minus 2 will become 6. When input voltage will become 10 minus 2 will become 8. Clear? And then what will happen? After 90 degree, you are supposed to getting back to the same waveform. This is up to 90 degree, I am drawing this waveform. After 90, again getting back to the same. Let us go back. Negative off. In the negative off cycle, see there, negative off cycle means we have to start from pi. Okay, sir, from pi to T3. First of all, from pi to T3 also, see there, negative voltage. Your negative voltages keep on increasing up to minus 2. But output voltage is 0, strictly 0. After minus 2, what is output voltage? It was become equal to minus Vn plus 2. Correct? That is what we had been observed. Let us see. When it is going for minus 2 plus 2 will become 0. Right? So up to this point, output voltage will be 0. When your input voltage will become minus 3, let us consider. Minus 3 plus 2 will become what? Minus 1. Then minus, when it is going from, this is minus 3, it will become minus 1. when it is going from, that is when it is going to minus 6, let me take some value. Minus 6 plus 2 will become what? Minus 3. When it is going to minus 10, minus 10 plus 2 will become what? Minus 8. So this is the transfer characteristics. Again, after 270 we are getting back same waveform, right? So this is how we are developing the transfer characteristics beautifully. Trust me dear, you will never face the question beyond this level. This is the maximum typical level you are going to face in your examination, okay? So your questions are very, very easy, right? So for your better understanding, I took this circuit. This is how we are developing transfer characteristics under the waveform, right? Of course, right? This type of waveforms will be tested in the interviews, right? Once upon a time, I was being tested with this type of questions, right? That's why I took this one here. Yeah, fine. So what is the next conclusion? Okay, sir, it's over. So this is how we are developing the, what I can say, clipper circuit, right? At last, I will give you one more circuit. You please draw. Now you please try. நம்ம ஏற்கனவே ரெண்டு எக்ஸாம்பிள்ஸ் கொடுத்துருந்தோம் இல்லையா உங்களை வரைய சொல்லி. I hope you all have drawn the waveform, right? I have not noticed how many of you posted the answer for that question. Anyway, let me draw up one more question here. Wait a minute. It's better. Let me take the last model. அப்படியே எடுக்கிறேன், ரைட்? பட் மாற்றி எடுக்கிறேன். மாற்றினா நம்ம இப்போ சீரியஸில் கனெக்ட் பண்ணணும் இல்லையா? இப்போ அப்படியே ஷண்டில் கனெக்ட் பண்ணிக்கோங்க. நான் அப்படியே, ரைட்? ஐ எம் நாட் சேஞ்சிங் எனி திங், ரைட்? ஃபார் யுவர் அண்டர்ஸ்டாண்டிங், டேக் சேம் சர்க்யூட், சேம் வேல்யூஸ். Just connect it in parallel with your output. Okay. It's better to keep some resistor here. Much better, right? Okay. I'm not changing any value, right? Yeah. Let us name this one as diode D1, diode D2. Your target is draw the waveform under transfer characteristics. See, the things that I am giving here, it is, why I am giving these things? You have to try. Because if you understand, then only you will be able to solve the question or examination. Spend some time because it is worth for 2 mark. I told you each and every mark will boost your rank to more than 400 or 300. Especially in TRB, TNB GATE, right? Last year GATE, around 30 lakh students over competed with us. Around 30 lakhs. So you have to, strictly you have to practice, right? As many problems as possible by yourself, right? It's not my responsibility. Similarly in TRB, TNB also, we know entire Tamil Nadu guys, right? Almost who are working for a TRB, that is in lecture, that is temporary lectures, private colleges, right? All of them are going to compete with you, right? So the conclusion is, should try to practice. Each and every mark will going to boost your rank above 1000 or 2000. It's very, very important, right? Okay, should try to develop the characteristics, transfer characteristics. I don't want this waveform. If you draw the transfer characteristics correctly, then it means what? Your waveform is correct, right? So simply post the transfer characteristics in the group. Don't discuss. That's what my conclusion. Don't make any discussion. Just to drop the answer. Fine. Let's wind up with this. So the next part is clamper. Tomorrow we will see the clamper circuits. Okay. Let's over with this. Thank you all.